Imagine stepping onto a train and gliding beneath the ocean, racing at over 250 kilometers per hour inside a tunnel longer than most cities and deeper than you'd ever dare to dive. This isn't a science fiction fantasy. It's China's newest mega project, the Jintang Undersea Tunnel, a project so audacious, so extreme, that many say Americans can't even imagine building something on this scale. China has been called the world's infrastructure maniac, not as an insult, but as a recognition of its unmatched ability to build big, fast, and bold. While many countries debate projects for decades, China just gets them done. In the past 20 years alone, China has built the largest dam in the world, the biggest water diversion project in history, and a high-speed rail system longer than the rest of the world combined. Now it's attempting something few thought possible, creating the world's longest high-speed rail undersea tunnel. The Jintang Tunnel will stretch more than 16 kilometers, with over 11 kilometers directly beneath the seabed. To put this in perspective, the UK-France Channel Tunnel is 50 kilometers long, but trains there run at only 160 kilometers per hour. Japan's Seikan Tunnel? About 54 kilometers, but trains are limited to 140 kilometers per hour due to safety issues. The Jintang Tunnel will be shorter, yes, but far more extreme, designed to carry high-speed trains at 250 kilometers per hour under crushing ocean pressure. Before we further explain, please subscribe to our channel, Travel Max, because it will help us to continue making more videos. Now, let's step into the engineering battlefield beneath the sea. Building this tunnel isn't as simple as drilling through rock. Along its path, the Jintang Line must cut through 28 geological transitions, shifting from hard rock to clay to loose sand. For most countries, this would be a nightmare. For China's engineers, it's a challenge to conquer. To do this, they've deployed two colossal tunnel boring machines, or TBMS, nicknamed Zhuhai and Yongzhou. Imagine steel beasts the size of skyscrapers lying flat. They're rotating cutter heads as wide as a 5-story building. Each blade is sharp enough to slice through rock and powerful enough to grind through seabed soil. These machines don't just dig, they fight their way forward, holding back the sea with layers of reinforced steel and precision engineering. And here's the breathtaking part. Zhuhai and Yongzhou aren't just digging blindly. They're guided by China's BeiDou satellite navigation system, correcting their path in real time. By the time they meet under the seabed, the alignment error must be no more than a few centimeters. Imagine two people digging tunnels toward each other from opposite sides of a mountain. If they miss by even a meter, the entire project fails. That's the level of accuracy required here, except with thousands of tons of machinery under ocean pressure. At 78 meters below sea level, the tunnel is under extreme pressure. Every square meter of its surface carries nearly 8 tons of force from the ocean above. That's like parking a fully loaded truck on top of a single sheet of glass. If even a hairline crack appears, seawater could rush in with the force of a jet engine, flooding the chamber within seconds. There is no room for mistakes. The biggest threat comes from two things: seawater infiltration. Saltwater corrodes steel, eats into concrete, and if left unchecked, can weaken the structure within years. Geological instability, tunneling through mixed layers of clay, sand, and rock, creates unpredictable shifts. Imagine drilling into butter, then suddenly hitting granite, and then sinking into wet mud, all while holding back millions of liters of seawater. To deal with these dangers, engineers turned the tunnel boring machines into something close to a submarine on steroids. The seals around the cutter head were reinforced with multi-layer pressure barriers that prevent leaks even if one layer fails. They installed active water injection systems at the cutting face. When sticky clay threatens to jam the massive blades, the system sprays water to lubricate and soften the soil, keeping the cutter head turning smoothly. Without this, the entire machine could lock up underground, leaving no way to dig it out. The drive system, essentially the engine that powers the boring machine, was also upgraded. In normal tunnels, consistent soil makes for smooth progress. But here, the constant switch between rock and mud means uneven resistance. To avoid breakdowns, the drive was designed with adaptive torque control, letting it deliver bursts of power when the cutter hits rock, but easing off when it moves into softer soil. This reduces strain on the system and prevents catastrophic failure. And then there's the human element. Working conditions are so harsh that crews can't spend long shifts inside. Specialized ventilation systems pump in fresh air, control humidity, and maintain safe pressure levels to protect workers from sickness or fatigue. Every time a worker enters the tunnel, they know they are one mistake away from disaster. But that's exactly why the systems are designed with redundancy, backup power supplies, and emergency pumps capable of draining thousands of tons of water in minutes. In short, the Jintang Tunnel isn't just being carved through the seabed, it's being defended against the sea itself. Every meter forward is a battle with nature, and the fact that progress continues is proof of how far tunnel engineering has evolved. But what happens when the machines finally meet underground? There's no exit waiting for them, no way to pull them out. The solution is almost poetic. Engineers shed the shell. The machines are dismantled piece by piece, leaving their massive steel casings behind, buried in the tunnel forever. Like skeletons of titans, silently reinforcing the very walls they created. When the Jintang Tunnel opens in 2028, it will link Ningbo to Zhoushan in just 30 minutes. That's not just a shorter commute, it's a complete transformation. Zhoushan, once a chain of isolated islands, will become fully connected to China's high-speed rail grid. This means faster trade, a stronger fishing industry, a busier cargo port, and direct access to one of Asia's largest petrochemical hubs. But here's where things get really interesting. Many experts believe the Jintang Tunnel is more than just infrastructure. It's a test run for something far bigger, a potential tunnel across the Taiwan Strait. At more than 130 kilometers wide, that would be the most ambitious undersea tunnel ever attempted in human history. If Jintang proves successful, it becomes the rehearsal for a project that could redefine geopolitics. Not just engineering, China isn't new to underwater tunnels. The Hong Kong-Zhuhai Macau Bridge project already includes a 6.7-kilometer undersea tunnel built with immersed tube technology. In that project, each tunnel section was the size of an aircraft carrier, weighing 76,000 tons. Engineers lowered them into the seabed with millimeter precision. That project alone consumed enough steel and concrete to build multiple Burj Khalifa towers. Jintang, however, pushes into uncharted territory by combining high-speed rail with extreme depth and pressure. Of course, these projects don't come without cost. Behind the glowing headlines, critics point to the hidden price: massive land acquisition, displacement of communities, and irreversible environmental damage. The Three Gorges Dam displaced more than 1 million people and forever changed the flow of the Yangtze River. Projects like Jintang also raise questions about sustainability, debt, and the long-term impact on fragile marine ecosystems. And yet, for China, these risks are secondary to the rewards. Infrastructure is not just about roads and tunnels. It's about national pride, global influence, and the belief that progress is something you build with your own hands. Every bridge, every railway, every tunnel becomes part of a bigger story: China's rise as an engineering superpower. So what should we make of the Jintang Tunnel? On one hand, it's a breathtaking display of human capability, a project that pushes technology to its limits and proves what's possible when ambition meets determination. On the other hand, it serves as a reminder that mega projects come with significant costs, often borne by those whose voices are rarely heard. But one thing is undeniable. Projects like the Jintang Tunnel are redefining the future. They show us that the boundaries of engineering are not set in stone. They're waiting to be pushed, deeper, faster, and bolder than ever before. The question now is not whether China can build it, but how far it's willing to go next. So, what do you think? Is the Jintang Tunnel a symbol of a new era of human achievement, Or is it an expensive gamble with hidden consequences? Drop your thoughts in the comments below. And stay tuned, because in our next episode, we'll uncover another mind-blowing mega project or a place to visit.